I'm David Yeaman, President and co-owner of Molded Precision Components here in Robotic. We're a precision plastic injection molder in the automotive and medical space. It all started in 1991 with my university career at Queen's University. Struggling academically and financially, I pushed my way through, but let me tell you, it was worth it. With that degree, I learned how to learn. I learned how to take problems and break them down and find solutions for them. I was resourceful, I could learn quickly, and I could solve problems. And applying that to industry went a long way. And that education led to a really rewarding career for over a decade, developing advanced manufacturing systems in the plastics industry. Utilizing that experience, in 2006, I joined forces with my business partner, Thomas Woger, also a fellow engineer, and we developed Molded Precision Components. And over a decade, we developed a lights-out manufacturing facility utilizing Industry 4.0 technologies, advanced manufacturing systems, and lean manufacturing principles. And the facility now makes 76 million parts overnight with nobody here. Then in March 2020, COVID hit. We were able to take our business model, vertical integration of advanced design, tool design and build, automation build, and implementation of advanced manufacturing systems, and develop a face shield capable of making 450,000 face shields a day, and shipped over 27 million face shields in less than 6 months to Canada's frontline workers. And that's how you apply advanced manufacturing technologies. In parallel to that, we developed an advanced manufacturing system for N95 masks, and the first of its kind in the world, advanced manufacturing system for sanitizer, where we can make sanitizer in one continuous flow from a pellet of plastic to a finished product on a skid, fully automated. And I love what I do because we get to create high-paying, meaningful jobs that take people from surviving to thriving and contributing to our communities. And nothing's better than that. Secondly, we get to be on the forefront of technology, developing new products and new manufacturing systems to help put Canada on the map. And in the next 5 years, we get to take everything that we've learned and apply it to developing Canada's first advanced manufacturing medical innovation park. 83 acres and 1 million square feet of world-class Canadian companies all collaborating together to manufacture Canada's health security needs. Not only for now, but in the future, by Canadians and for Canadians. And all the while, I get to play with robots. So the reason why MPC works with Georgian College is first and foremost because one of our core values is about helping youth reach their full potential. And we do that by hiring co-op students to help giving them real industry experience and eventually, ideally, giving them long-term jobs. We also sit on advisory boards of Georgian College to help develop the engineering programs and precision skills programs to ensure that those programs match what the industry needs are. Georgian brings to us an expertise in automation, controls, electrical and mechanical build of automation systems. And that value allows us to execute projects we otherwise would not have been able to execute. The other thing that's really important is that it's a transfer of knowledge both ways. From industry to the college, from academia, and back to industry again. And that closes the loop and allows companies to be able to grow while we foster kids into the workforce. One of the business challenges that MPC was faced with was that we had developed this new advanced manufacturing technology in the automotive space using cube technology in order to manufacture complex automotive components at half the cycle time as anybody else in the world. But what we were missing was the automation systems that we needed to put in the inserts, to be able to remove finished products, to inspect them and package them. And that's where we went to Georgian, and they brought in their expertise to help us out. And this new technology that we've collaboratively developed together will help us be more competitive on the global stage. So as we all know, this was actually a collaboration. So instead of me talking all the time, let's involve some of the team. So Amur, you want to explain to people about what exactly we did here?
Sure. We worked together to develop the idea, design a fully automated robotic line, including all the robot 6-axis robot vision system, programs, PLC, programmable controllers, to put everything together and make a fully automated system.
So that was the what we did. So Joseph, why don't you tell us a little bit about how we went about it with Georgian College?
We collaborated with the students and faculty at Georgian to design, build, and integrate the system.
Right, excellent. And Sam, what was your role in this whole?
It was to help facilitate the finances and timelines, as well as to help with the collaboration of communication, both during meetings and outside of the building.
Okay, so now we talked about the what we did, how we went about doing it, collaborating with the college, how we managed it and pulled the whole thing together. I'd like to hear from Umo now, as a Georgian student, about what you learned about going through this process.
This project has helped me apply critical thinking and solving problems in an industrial setting, and it has helped foster my knowledge and understanding of how to apply things that have been taught in school and in class settings into an industrial setting that would help bolster me in the employment field.
Right, that's amazing, because that's exactly what this is designed to do. So let's hear from the faculty a little bit. Andrew, as a faculty member, tell me a little bit about what doing projects like this means to you.
Well, for me, it's really important. I think to transfer knowledge that I have, that I've gained through my years of experience on the job to the students, and have them see what real world industry is like and what they can expect to see once they get out on the job. Like, you get to see the transition from a student that doesn't maybe know quite as much on the job, to seeing them transition into a role where you view them as peers and stuff like that. So it's exciting to be able to see that.
I'm David Yeaman, President of Molded Precision Components here in Oro-Medonte. When the pandemic hit, we were manufacturing automotive components and venturing into medical. When the automotive went to virtually zero overnight, we retooled and we developed new facilities to help supply Canada's PPE needs. We partnered with Sterling Industries, the federal and provincial government, and we developed Shield U, a Class 1 medical device face shield, and manufactured 27 million face shields to support Canada's frontline workers. And we donated 25,000 to our communities. And all of that led to this. Canada's first advanced manufacturing medical innovation park, 83 acres of company collaboration to permanently establish Canadian capacity to supply Canada's health security needs for Canadians and by Canadians. And what makes me truly hopeful for the future is seeing how Canadians all pull together during this crisis. The public, industry, and government all collaborating and innovating together to fight this fight together. And this park is evidence of that. And by the way, we're still making automotive components.
So just a snapshot of how one Canadian, David Yeaman, has managed to make his business work even in a pandemic.
When this pandemic hit, the Canadian government called on businesses to pivot and in some cases turn their attention to help supply some of the products that would be needed to fight off the pandemic. One of those businesses was Molded Precision Components. Its CEO or president, David Yeaman, is with us now. David, thank you for being with us. Let's go back to the pivot that you had to make. I mean, you're an advanced manufacturer. What was the first thing that you realized you were going to do, and when did you start doing it?
Yeah, well, we saw it coming as it was coming from China. So really in the new year, I knew that the automotive industry was going to start coming to a halt. So we started thinking very, very early. And we started hearing the call from the federal government and the provincial government for PPE. In March, we had pivoted and designed and developed a face shield. And we partnered with Sterling Industries, and in 1 week we had developed a design, did 31 different prototypes, patented that technology, and by the Monday had partnered with Engen and got funding to build that capacity out. And we built enough capacity in new facilities to build 450,000 face shields a day, and we supplied 27 million face shields to the federal government and the provincial government to support frontline workers. Later, that led to more requests for bottles and caps and masks and test kits and you name it. So as we saw there was more needs, we actually started looking at how else we can help with the skill sets in which we had. And being a plastic molder, we looked at the sanitizer market because people were starving for bottles and caps. They had nothing to put it into. When NGen had put out another COVID supply challenge, we saw that and saw it as an opportunity to develop a new advanced manufacturing system for manufacturing hand sanitizer. So we won that challenge, and they're awarding us a $5 million grant in order to build that out. It's going to be about a $20 million project, but it'll be the first of its kind advanced manufacturing sanitizer system that allows us to make sanitizer from a pellet of plastic to finished material on a skid, frankly, with nobody touching. It includes the bottle manufacturing, caps, the filling, and packaging, all in one continuous stream. And that project will save about 5,000 tons of CO2 a year alone in just getting rid of the warehousing, shipping, and receiving, and all the waste that's in the traditional global supply model.
You mentioned NGen. For folks that don't know it, that's the government's advanced manufacturing supercluster. How has that influenced you or changed what you do in other ways? Was this the first time it had a direct influence on what you would do in your business?
Well, actually, we have a long-term relationship with NGen. Pre-pandemic, we were already working on some other advanced manufacturing technologies in collaboration with Nigon Industries to develop some new automotive technologies in the molding world. So we're working on a pilot project for that. So we were already well positioned with NGen in advance. So having those relationships, collaborative relationships advance with FedDev and NGen and IRAP and those type of agencies were really instrumental for us to be able to move quickly because we knew their systems and we knew their programs really well. But frankly, without NGen stepping in here, we wouldn't have had the capital to get off the ground. Of course, we have to put money in as well, but we needed that initial seed money to get started. And in order to pivot and move as fast as we did, without them, we wouldn't have been able to operate the way that we did.
You know, and obviously pivoting is something that you're able to do. You were able to retool in less than 2 months. How do you do that? What is the secret to being able to be that responsive?
First of all, it's your people. So all of our people stuck with us. We immediately put in protocols to keep people safe. Not a single person went home. Actually, one did, but they built themselves an isolation room from their parents such that they can come back to work right away. So we had a strong foundation of good, solid engineering expertise. We're a vertically integrated company where we have design in-house, tooling. We build our own tools, we build our own automation, and we build our own mass manufacturing systems. So being vertically integrated and not needing anybody from the outside world in order to execute this was the model that ultimately made us successful to be able to move, because there was nobody stopping us from doing what we're doing other than getting the base raw materials, which wasn't a problem at the time. You know, we took that same model. We've actually bought 83 acres of property in order to build out a medical innovation park, the first of its kind in Canada, to build out that same vertical integration model where that park would be full of collaborating companies that all complement each other, so that is a supply base that's built all within the park. So it's like having a mass manufacturing plant for all PPE needs and medical supplies to support Canada's health security needs. So we're going to continue to apply that vertically integrated model and help build out Canada's permanent capacity for making sure that in emergency response situations we'll never be in this situation ever again.